Hi guys, today I'm going to be talking to you about black holes and what they have to do within our universe. I hope you enjoy the presentation. Firstly, I'm going to be discussing intergalactic distances, starting as small as a city to as big as a galaxy. Then I'll be moving on to stars and their life cycles. This will lead me on to talk about gravity, which will then bring me to relativity.
Black holes and time travel.
Okay, first things first, intergalactic distances. This here is a picture of my hometown, Brisbane, the capital of Queensland. This is probably the biggest thing a human could possibly comprehend, so I'm going to start here. Brisbane City is approximately 100 kilometres in diameter. Next is my home country, Australia. The red dot you see is about the size of Brisbane. Australia is 40 times the size of Brisbane, making it 4,000 kilometres wide. Okay then, as you can see, very quickly we are getting to larger and larger distances. We are now up to the world, which is approximately 10 times the size of Australia. The world is 40,000 kilometres in diameter. Now, if you thought that was big, then that's nothing. If you take the Earth and you multiply it by 150,000, that would be the distance from the Sun to Pluto, or in other words, 6 billion kilometres. And last but not least, a light year. A light year is a measurement currently used in space and is equal to 2,000 times the distance of the solar system, or 10 trillion kilometres. So when you hear that something is only 7 light years away, you now know that that is equivalent to 70 trillion kilometres. By the way, a galaxy, in which you can see in the background of this image, is thousands of light years. I only use this for representation. Now that that's cleared up, here's a recap. We start off with my home city, Brisbane. We then multiply the size of Brisbane by 40 to get the size of Australia. Multiply the size of Australia by 10 and you have the Earth. Multiply that again by 150,000 and you have the solar system. And if you multiply the solar system by 2,000, then you have 1 light year. If you multiply the Earth by 25 million, that will give you the size of 1 light year. If you multiply Australia by 250 million, you will have a light year. And if you multiply Brisbane by 120 billion, you will have a light year. So there you have it. The universe is very big, and so is a light year. And a light year is the smallest unit of measurement in our universe. Okay, now we're on to stars and their life cycles. The life cycle of a star begins with a whole heap of gas and dust and other stuff maybe floating around in space, all floating randomly. This material can be found about 1 light year across, keeping in mind that that's 10 trillion kilometres. The life cycle of a star begins with a whole heap of gas and dust and other stuff maybe floating around in space, all floating randomly. This material can be found about 1 light year across, keeping in mind that that's 10 trillion kilometres. Most of this stuff is hydrogen, hydrogen being the most common element in the universe, making up about 95% of all matter. The big ball of gas, 10 trillion kilometres wide, is being brought together at incredible speeds through gravity, starting off slow and getting faster and faster. Eventually it will condense to the point that it will be so jam-packed that hydrogen will fuse together to create helium. This releases huge amounts of energy, more than any atomic bomb ever created. This is the birth of a star. A star will go on fusing hydrogen to helium for many billions of years. A star will go on fusing hydrogen to helium for many billions of years. A star will go on fusing hydrogen to helium for many billions of years. But what happens when hydrogen runs out? Well, the star will move A star will keep burning fuel and generating enough heat so that gravity won't pull it in completely. Eventually, a star will get to the point where it fuses iron. This is as far as it can go because iron is a metal and therefore absorbs energy and heat instead of fusing it to release energy. The result is the whole sun collapsing in on itself, and then this explosion is called a supernova. After the explosion, the star can end in one of three ways. This explosion is called a supernova. After the explosion, the star can end in one of three ways. It could turn into a white dwarf, as our sun probably will, burning away for eternity until it turns into a black dwarf, if it doesn't get sucked into a black hole or something before then. Or it will become a neutron star, an extremely dense ball of matter where 1 teaspoon weighs thousands of kilograms. Or it will end its life so densely that it rips a hole in space-time, creating a black hole. So here's a recap of the life cycle of a star. It starts off as a nebula or a large ball of gas, then sometimes becomes a sun-like star, which becomes a red giant, meaning it swells up before exploding, then explodes and becomes a white dwarf. Or it could become a massive star, swell up to a super red giant, then go supernova, either becoming a neutron star or a black hole. Next is gravity and relativity. Gravity is that annoying force that makes you trip over, and its main purpose on Earth is to pull things down towards its center, such as us. Gravity was discovered by the whiz-head scientist Isaac Newton, who discovered it while sitting under an apple tree while an apple fell on his head. He wondered, why didn't the apple fall up? From there, Newton invented his laws of motion, wrote 3 1,000-page books to explain his 3 laws of motion, and then sent a man to the moon. Newton's laws. Law 1, the law of inertia. Inertia states that an object will keep moving unless another force, such as a wall, stops it. Law 2 shows the relationship of force, mass, and acceleration. Law 3 states how rockets get to the moon. Relativity. Relativity states that the more mass an object has, the more gravity. The more gravity an object has, the more it warps space-time. And in this picture is an experiment that proved this right. Some objects are so massive that they warp space-time so much that it creates a hole in the universe called a black hole. Okay, finally, last but not least, time travel. Most people have heard of E equals mc squared. The E stands for energy, the M stands for mass, and C stands for the speed of light. This basically means the more energy, the more mass. We know from relativity that the more mass equals the more gravity, which means most people have heard of E equals mc squared. The E stands for energy, the M stands for mass, and C stands for the speed of light. This basically means the more energy, the more mass. We know from relativity that the more mass equals the more gravity, which means more warping of time. From this, we can gather the more faster we go, the more energy we need to make, and the more energy means more mass. So if you could travel near the speed of light, you could basically warp time and time travel. Thanks for listening.